Hello friends, today I will start retrosynthesis and its applications. First of all, terms used in retrosynthesis. First is a target molecule, second disconnection, third synthon, fourth synthetic equivalent, and last one is functional group interconversion. First target molecule. It is indicated by Tm, the molecule whose synthesis is being planned is termed as target molecule and is usually written as Tm. For example, if you want to synthesize tertiary butyl alcohol CH3 thrice COH, then tertiary butyl alcohol is the target molecule. Then disconnection. Disconnection is a imaginary analytical operation which break a bond and convert a molecule into a possible starting material or materials. It is the reverse of a chemical reaction. It is denoted by a symbol, two-sided arrow and a curved line drawn through the bond that is imagined to be broken. For example, tertiary butyl alcohol CH3, which on a disconnection and also OH bond is break, and then the formation of carbon oxygen double bond, then the formation of ketone plus CH3 minus plus H plus. These two are synthon. Next, synthon. Synthon, it is imaginary fragment, usually an ion, which is produced by a disconnection. This could be used to synthesize the molecule. For example, CH3 minus produced in the disconnection shown earlier. Then next is a synthetic equivalent. It is a reagent which can be provided the required synthon. The synthon CH3 minus can be provided by the reagent CH3MgX, a Grignard reagent. Here MgX is the synthetic equivalent of synthon CH3 minus. Then last one is a functional group interconversion. It is the operation of writing functional group for another so that this connection become possible. Again, it is a reverse of a chemical reaction. FGI is written as the symbol two-sided arrow. When ketone, which on functional group interconversion, that gives alcohol. Also halide, which on a FGI, that gives alcohol. For example, tertiary butyl alcohol in root first. The disconnection of tertiary butyl alcohol, the CH3 is disconnect, then the formation of carbocation is a synthon plus CH3 minus. These are two synthon. Then oxygen hydrogen bond is break, and then the formation of carbon oxygen double bond is a synthetic equivalent, and also CH3MgX is the synthetic equivalent of synthon CH3 minus. Then synthesis. Methanol, which on a react with phosphorus pentachloride or thionyl chloride, that gives methyl chloride. OH is converted into chlorine. Then methyl chloride react with Mg ether, that gives CH3MgCl. When methyl iodide, which on a react with Mg ether, that gives CH3MgI. Then Grignard reagent is then reacted with acetone. Acetone react with CH3MgX. In CH3MgX, the CH3 is a negative and MgX is positive. This negative alkyl group, which when attack on a carbonyl carbon, then carbon oxygen bond is a break, and then the formation of negative charge on oxygen. Then after hydrolysis, this negative charge abstract hydrogen, then the formation of tertiary butyl alcohol as a product. This is a functional group interconversion. Then retrosynthesis and synthesis of target molecule. The example is acetophenone. Acetophenone is a target molecule. First, there is a disconnection of acetate group, then the formation of negative charge on benzene ring and positive charge on carbonyl carbon. Then there is a presence of two synthone molecule. Then after addition of hydrogen to the synthone, then the formation of synthetic equivalent. The product is benzene. Then this carbocation addition of one negative chlorine atom, then the formation of acyl chloride is a synthetic equivalent. Then in second route, disconnection of acetate group, then presence of positive charge on benzene ring and negative charge on carbonyl carbon. As benzene is an electron-rich species, positive charge cannot be accommodated on the benzene ring. Hence, as compared to route B, route A will be the proper route of synthesis of target molecule, first acetophenone, then the synthesis of acetophenone. Benzene, which on react with acetyl chloride in presence of anhydrous AlCl3, that gives acetophenone. It is a Friedel-Crafts acylation reaction. Then the mechanism of this reaction, acetyl chloride which on react with AlCl3, then chlorine is a good leaving group, it is a remove, then the formation of carbocation and then AlCl4 minus. These two are synthone. Then in second step, benzene which on react with acetate, then the formation of acetophenone as a product. Then crotonaldehyde. The crotonaldehyde, first of all, it is also called as alpha beta unsaturated aldehyde. First, crotonaldehyde, which on a functional group interconversion, then carbonyl is converted into the alkene is converted into alcohol. Then after this connection, there is a presence of two synthone and synthone which are converted into synthetic equivalent. Then synthesis of crotonaldehyde. In first step, acetaldehyde which on react with NaOH, first base which abstract the alpha proton, then the formation of carbon ion or synthon, and then this negative charge shifted, then carbon carbon double bond is formed and carbon oxygen double bond is a break, and then the formation of enolate. In second step, second molecule of acetaldehyde which on react with enolate, then this negative charge on oxygen which on shifted to carbon oxygen double bond is formed, and then carbon carbon double bond is shifted to the carbonyl carbon, and then simultaneously carbon oxygen double bond is break and the formation of negative charge. Then after addition of hydrogen, then the formation of aldol as a product. Then in third step, after removal of water molecule to the aldol, and then the formation of crotonaldehyde or alpha beta unsaturated aldehyde as a product.